Hello, food and nutrition researchers. In this video, we're going to talk about data storage, security, and sharing. Proper data management is not just essential, it's the bedrock of maintaining scientific rigor and research integrity. Before we dive into the details, let's talk about why data management is important. From collection to analysis, all data must be properly stored and protected. This ensures that your research is valid, reproducible, and can withstand scrutiny. Research data management is the cornerstone of a successful research project. Thinking about how data will be stored and used should begin before data is even collected. Effective planning for data management involves not only addressing current data collection, but also anticipates how you'll utilize your data in the future. This could include how you could potentially share it with colleagues for further use in other studies. The way you arrange and store your data will significantly impact your ability to locate, handle, share, and reuse it in the future. Implementing a clear and user-friendly system of folders and file structures will simplify the process of finding specific data components. Randomly naming files and placing them in disorganized folder arrangements will not be advantageous to you or to anyone seeking to utilize your data down the road. You should also consider any limitations on where you can store your research data as dictated by institutional guidelines, funding agencies, or specific requirements from collaborators related to data security and transfer. It's crucial to address this early in your work as it will safeguard your data and ensure compliance from the start. Here are some good practices in storing data to remember. First, choose the storage media wisely. It's essential to choose a secure and reliable system that suits your research needs. Types of data storage could include portable devices that can be used for storing short-term copies of data files for transport or transfer purposes. Cloud services can be suitable when collaborating with partners from outside your organization, and university network drives can be suitable when collaborating with others from within your own university. Second, make sure to manage the versions or copies of your data carefully. Store your raw data in a separate protected location, preferably as a read-only version, and make working copies of those files for your actual analysis. Make sure to back up the master copy or your most recent or correct version in a physically distinct location. As you'll have to make several versions from your master copy, set up a strategy for version control. Versioning can help track the development of a data file and identifies earlier versions when needed. Next, make sure to logically structure folders or file names. As your work progresses, it's likely that you'll have more folders, all with different content. Finding the exact file that you need can be a hassle if you do not have a logical folder structure or logical file names. Also, take into account any metadata associated with your data. Metadata and accompanying documentation offers details about your data, such as project subjects or the conditions surrounding data collection. Without metadata and documentation, much of the data remains as mere numbers without any significance. Therefore, this data about data is essential for comprehending, locating, reusing, and effectively managing the context of your data. Also, use standard file formats. Not all formats are equally accessible for everyone. Therefore, using standard file formats to store your data is important. Consider how you should secure your data files. There are several tools to help you protect your data files. For example, remember locks. Lots of copies keeps stuff safe. This ensures that you have backup copies of important data in multiple locations so that you can restore it quickly in case of data loss. You can also follow the 3-2-1 principle. This ensures that you have at least 3 copies of anything important stored on at least 2 different medias with at least 1 copy in a different geographical location. Lastly, consider encrypting your data. Protecting sensitive, confidential, or commercially valuable information is a complex task. Encryption can be helpful in maintaining the confidentiality of the data. In collaborative research endeavors, data sharing is essential. Sharing scientific research data offers numerous advantages. It leads to more robust initial publication data by enabling peer review and validation of datasets and methodologies before publication. This practice enhances the credibility of research data and fosters transparency, both of which play a crucial role in bolstering the trust in the field of science. Once published, data sharing encourages further scientific exploration and progress by providing other researchers with the opportunity to examine and build upon the shared data. This is particularly important for researchers in developing regions who have limited funding and often bear a disproportionate burden of the costs linked to generating new data. Data retention is another crucial consideration in data management. Be sure to determine how long you need to store your data to meet institutional guidelines or funding agency requirements. For example, many institutions mandate that data and research records be retained for at least 3 years after research completion, but certain institutions stipulate more extended retention periods. Therefore, it's advisable to factor in all these aspects before starting on your research project. As researchers, you'll often find that research agencies require a funding management plan as part of your grant proposal. This plan outlines how you intend to handle, store, and share your data during and after the project. Fear not, though, many funding agencies like the National Institute of Health provide guidelines on how to prepare a data management plan. Also, the FAIR guiding principles for scientific data management and stewardship are an excellent framework to ensure that your data is findable, accessible, interpretable, and reusable. Now let's discuss how these apply to food and nutrition specifically. In the US, salmonella infections continue to rise. It's estimated that 1.35 million salmonella infections occur every year. In order to combat this, the USDA Food and Safety Inspection Service is conducting risk assessments to help inform and create more effective regulatory policies to reduce salmonella infections. However, these assessments require large, comprehensive data sets, more than the USDA FSIS has alone, to ensure the accuracy of the results. Therefore, public-private partnerships for data sharing have been established to determine a mechanism to effectively and safely share data between sectors to support more effective policies and reduce salmonella illness in the United States. With proprietary information and industry interests, sharing data openly might seem challenging. It's crucial to find a balance between collaboration and protecting sensitive information, which demonstrates the importance of data management practices. Regardless of the research area, data privacy and protection must be top priorities. Ensuring that personal and sensitive data are safeguarded not only holds research integrity, but maintains the trust of your participants and stakeholders. Let's recap what we've learned. We've explored the pivotal role of data management in maintaining scientific rigor. We've discussed best practices for storing and sharing data, and considered a real-world example that demonstrates the importance of data management and sharing. From data storage options to privacy considerations, every step in the process contributes to the overall quality of your research. As researchers in the food and nutrition field, you play a critical role to uphold data management practices while advancing knowledge, which ensures public trust in the research. Thank you for watching this video to explore the intricacies of data storage, security, and sharing. Keep up the great work, researchers.